Hey everyone! Yesterday we made our first neural network, but there were many terms hanging around. It was like of backpropagation, the forward pass, the gradient descent, and many more. This video is going to be more of theoretical part and we will learn about these multiple terms. Let's quickly begin. Firstly, deep neural network is nothing but perceptron plus few ingredients. So these ingredients are nothing but the terms which we will learn today. In artificial neural networks, the activation function of a node defines the output of that node given an input or a set of inputs. A standard integrated circuit can be seen as a digital network of activation functions that can be either on or off, that is 1 or 0, depending on the input. This is similar to the behavior of the linear perceptron in neural networks. However, only nonlinear activation functions allow such networks to compute the non-trivial problems using only a small number of nodes, and such activation functions are called nonlinearities. Then comes the backpropagation. The backpropagation is the essence of neural net training. It is the method of fine-tuning of the weights of a neural net based on the error rate obtained in the previous epochs, that is the iterations. I think by now you're aware what is an epoch and what is a batch. Proper tuning of the weights allows you to reduce the error rates to make the model reliable by increasing its generalization. Backpropagation is nothing but a short form of backward propagation of the errors. It is a standard method of training neural artificial networks. This method helps to calculate the gradient of a loss function with respect to all the weight in the network. There can also be certain advanced architecture of the deep neural network. These can be in the form of RNN, which is the recurrent neural network, CNN, that is the convolutional neural network, and then is the generative adversarial networks, that is the GAN. We will also go through this architecture as we go along with the videos. So by now you should be clear with what is an activation function and the other hyperparameters, what is backpropagation, and then what may be the advanced architecture of the other deep neural networks. Now let's understand what a forward pass is. The forward pass refers to the calculation process values of the output layers from the input data. It's traversing through all the neurons from the first to the last layer. A loss function is calculated from the output values. Backward and the forward pass together makes up a single or a one iteration. If we talk about error function, it is nothing but the difference between the predicted and the actual value, and hence my error function or loss function or an objective function, this should be as near to 0 as possible because we want our predicted values to be very accurate. Then comes the most important concept of the gradient descent. Gradient descent is the first order iterative optimization algorithm for finding a local minimum of a differentiable function. To find a local minimum of a function using the gradient descent, we take steps proportional to the negative of the gradient or approximate gradient of a function to the current point. Parameters refer to the coefficients of a linear regression is approximately equal to or similar to the weights in the neural network. So now we know what is a forward pass, then comes the gradient descent and what is the weight in the gradient descent. So the weights are updated as per our hyperparameter tuning, that is the epochs and the batches. The forward pass gives a prediction and then the backward propagation is performed on the aggregated results. Let's little bit deep dive into the gradient descent because this is the base of any type of neural network. Now you can see a diagram here where there are three persons or the three positions. One is near to A, one is near to B, and one is near to C. Consider that you are walking along this particular path and now you are at a maximum position, but you want to reach the local minima. That may be for position 1 it may be A, for position 2 it may be B, and for position 3 it was going to be C. But now you cannot see these minimal points. This means that you do not know what next step you should take. Possible actions is that you might go a little bit upward or you might go a little bit downward. If you decide on which way to go, you might take a bigger step or a little step to reach your destination. Essentially, there are two things that you should know to reach the minima. That is, which way to go and how big your step is. Gradient descent algorithm helps us to make these decisions efficiently and effectively with the use of the derivatives. A derivative is a term that comes from the calculus and is calculated as the slope of the graph at a particular point. The slope is described by drawing a tangent line to the graph at that point. So these becomes my tangent for this particular point. So if I see the derivative at this particular point, if I draw a line this way, that is going to be my tangent. So if we are able to compute this tangent line, we might be able to compute the desired direction to reach the minima. This size of the steps taken to reach the minimum or bottom is called the learning rate, which is very important to understand. We can cover more area with the larger steps or higher steps, which is known as the higher or the larger or lower learning rate. But there is always a risk to overshoot the minima if your step becomes very large. On the other hand, small steps or the smaller learning rate will consume a lot of time to reach the lowest point. So we have to choose this learning rate very wisely so as to correctly and optimally reach the local minima. Now, as a next step, let's deep dive into backpropagation and how things are calculated in the backpropagation. If you can see this neural network, it's very similar to a perceptron, but where we are having multiple layers. My two inputs are I1 and I2, and this one which we have considered as the bias is we have given the value of 1. We are having a hidden layer H1 and H2, and then my ultimate output is O1 and O2. Now if someone asks me what is H1 or what is the mathematical value of H1, I can easily say that is going to be I1 into W1 plus I2 into W2 plus 1 into B1, which is equal to H1. Similarly, I can calculate it for H2. It is going to be W3 into I1 plus W4 into I2 plus B1. This is going to be H2. Now, if someone asks me what is going to be O2, it is going to be, firstly the input is coming from H1 into W7, then it is going to be H2 into W8, and then it is B2 into 1. Hence, in this case, I can say that my O2 is dependent on H2 and my H2 is dependent on I2 as well as I1. O2, the value of O2 is dependent on H1 and H2. Value of H2 is dependent again on I1 and I2, and similar for H1. So all my layers are not independent, they are dependent for each and every last values or the last neurons. And hence activation function here plays a very important role so as to give the output that which particular neuron it should trigger. Now as a next step, what we have done, we have assigned some weights to these values. That is, we have said, let's say my I1 is 0.05 and my I2 is 0.10. My ultimate goal is to have the values of O1 as 0.01 and O2 as 0.99. So goal of the backpropagation is to optimize the weights so that the neural network can learn how to correctly map the arbitrary inputs to the outputs. We have randomly given some weights, that is 0.15 to W1, 0.20 to W2, 0.25 to W3 and 0.30 to W4, and my B1 is having the value of 0.35. So from these all values, I'm going to calculate H1 and H2. Once I calculate H1 and H2, I'm going to calculate my O1 net and O2 net, and then we'll try to find the difference between the predicted value, which were depending on all the weights, and the expected value, which is 0.01. Now let's go a little bit of the calculation for these values. We already know the different values of the coefficients. So net H1 is going to be W1 into I1 plus W2 into I2 plus B1 into 1. So if you go back to this diagram and see all the values of 0.15, 0.20, 0.25 and 0.30, you can put these values in the equation and I can get my net H1 is equal to 0.3775. Now, in this particular example, we are using the logistic function. Therefore, the output of net H1 is going to pass through the logistic function or the sigmoid function, where the formula is output is equal to 1 divided by 1 plus e to the power minus output. So my output has come 0.3775. Now when I calculate the output, it is going to be 1 divided by 1 plus e to the power minus 0.3775, which is equal to 0.59327. We are going to do the similar calculation for H2. If I calculate H2 by the same formula, then the output after my logistic function is going to be 0.59688. Now, from this diagram, we already have my value of H1 and H2. Whatever steps we had followed for calculating H1 and H2, the similar steps we will be following to calculate O1 and O2. Once we calculate O1 and O2, the output of O1 comes out to be 1.1059 and output of O2 comes out to be 0.772928. So I was expecting an output of 0.01 and 0.99, and the output which I got is something like 1.105, 0.751 and 0.772. Let's move further now. If I try to calculate the error, my error is going to be sigma of half into target minus output square. My target was 0.01 and my output is 0.75. Therefore, my error of O1 is equal to 0.278. Similarly, when I calculate it for E2, it is going to be 0.0235. Now, if I want to calculate the total error, I'll just do the summation of both, that is E total is equal to E01 plus E02, which is equal to 0.2748 plus 0.02356, which is equal to 0.2983. So now I am having the total error, but my objective function is to minimize this particular error so that I can have my output very much near to my actual output. Now the importance of backward pass comes. In the elementary maths, you must have learned or you must remember what was the chain rule. What we are trying to achieve here is that we are applying the partial derivatives. Minimizing the partial derivatives means that we are trying to minimize the difference. We will update each of the weights in the network so that they cause the actual output to be closer to the target output, thereby minimizing the error for each output neuron and the network as a whole. So my E total was equal to half of target of output 1 minus output 1 whole square plus half of target of output 2 minus output 2 whole square. If I take the partial derivative of this E total with respect to output 1, this is the output 1. The output which I'll get is this square comes here. So 2 into half of target 1 minus output 1 to the power of 2 minus 1 as per the rule of differentiation minus 1 plus 0. So this is my output. This is my differentiation factor that I get, and my calculations come out to be 0.741. Now we will see the change of output 1 with respect to W5. where output 1 is equal to 1 divided by 1 plus e to the power minus net of output 1. We are going to take the partial derivative with respect to net of output 1, that is d of output 1 with respect to d of net output O1. So this is the output that we are getting, 0.1868. We also know what is the formula of net O1, that is with respect to W5 and output of H1. This also we calculate, which comes out to be 0.5932. Now we will put all the values together as per the chain rule, that is derivative of E total with respect to derivative of W5 is equal to derivative of E total with respect to output O1 into derivative of output O1 with respect to net O1, then into derivative of net O1 with respect to W5. If we put all these values, we can calculate the value of W5, which comes out to be 0.358. When you can see this eta is nothing but it is the learning rate that you have to choose in every iteration. We will apply similar method for all the different weights that was present earlier. So the different weights which were present was W1, 2, 3, 4, 5, 6, 7, 8. We will calculate all the weights together with this backward pass process. Based on that, we will get the different values. The values are like W2, W3 and W4. We have repeated it and got different values. Once your weights is updated, you are again going back to this diagram where you will replace these values with the new weights, and hence full process the next iteration will be done again in the same manner that was completed here. And you will be able to see that you are much closer to the output now. Now this iteration will take place in loop. When to stop the iteration depends upon how much minimization of the objective function you want. Less the objective function loss function, that is the difference between the output and the input, the less the value of it, better your model is. So the main thing that we have learned in this video is that firstly, in the forward pass, first we are randomly giving the weights. Once we are giving the weights, then we are trying to see what is the difference between my output and input. Then using the chain rule, we are using the partial derivatives to update the different weights and the bias. Once we update this weights and the bias, again the forward pass does. So a single iteration in a neural network means one forward pass and one backward pass. That means in my first iteration, my weights are already updated. Now, depending on the values of the epochs and the batches that you choose, the epochs for number of iteration is going to be considered as per the epochs that you decide, and hence let's say if you consider 10 epochs, so the iteration is going to be 10, and hence your weights and the bias are going to be updated 10 times. So whatever result you will get after the 10th iteration, that is going to be your final result. So this way you can update all the weights in each iteration, and objective of our full neural network creation is that we have to minimize our objective function, or you have to minimize your loss function. So this way now you have understood how mathematically forward pass and backward pass takes place, what is the main goal of gradient descent, how we are calculating the slope, why tangent is important, how we can reach to our local minima. Please repeat the video as many times as you want to understand it. Take a pause in the video, try to calculate it with pen and paper, which will give you a better understanding. Until and unless you understand this particular calculations mathematically, you will not be able to move forward with the development of the actual neural networks. Any doubts, please give it on the comment section. I'm always here to help you with all your doubts. I think for now, that's all about the video. Please subscribe and like if you like the video. Thank you.